The rain was falling upward. Droplets that should have splashed against the cold asphalt instead rose gently into the night sky, like fragments of memory returning to their source. The city lights shimmered through the mist, bending and stretching as if reluctant to stay fixed in one place. Somewhere in that motion, a heartbeat echoed, not forward, not backward, but inward, folding into itself. The air seemed to hold its breath. Something impossible had just occurred, though no one could name it. For a moment, the world stood still, and time itself seemed to hesitate, uncertain of which direction to go. We have always imagined time as a river, restless, unbroken, flowing from the past toward a waiting sea of tomorrow. But what if that river could curl back upon itself? What if, instead of an arrow, time was a loop, a spiral, a fold? The thought alone feels forbidden, as though we are trespassing on the structure of reality itself. Yet deep within the equations of our greatest minds, whispers of such a possibility begin to appear, small anomalies in the smooth fabric of the cosmos that suggest time may not be as loyal to forward motion as we believe. Imagine a world where your first breath and your last happen at once. Where the explosion of a star and the birth of a child coexist, side by side, like pages pressed together in a closed book. In this world, moments are not lost. They are layered, each second a fold in an infinite sheet of existence. Our memories, our expectations, even our very sense of now, might simply be the way our consciousness schemes across that folded surface, one crease at a time. It begins with light. Light, the messenger of time, the one constant that seems immune to change. We measure distance by it, reality by it, history by it. But what happens when light bends, when gravity itself drags it from its straight path? Einstein taught us that spacetime curves, that mass and energy shape the flow of everything around them. But a bend is only the beginning of a fold. Somewhere beyond the stars, perhaps near the edge of a black hole, spacetime may not only curve, it may double back, twist into itself, and vanish behind its own horizon. To visualize it, close your eyes. Picture the universe as a vast sheet, stretching endlessly in every direction. Now imagine pressing 2 points together, yesterday and tomorrow meeting face to face. The space between them collapses and distance disappears. In that instant, the separation we call time ceases to exist. Past and future touch. The present dissolves. If this sounds like fantasy, remember that the boundary between science and wonder has always been porous. Once, lightning was divine fire. Once, motion itself was a mystery. Every time we have thought we understood reality, a deeper layer revealed itself, an invisible world behind the visible one. Perhaps time, too, hides another truth behind its familiar rhythm, something we can feel but cannot yet name. But if time can fold, what happens to us, the observers trapped within it? Do we move through the fold, or does the fold move through us? Are we the travelers, or merely the witnesses of an eternal motion that only appears to flow? These questions linger in the air like smoke, refusing to settle. They are both scientific and sacred, both terrifying and beautiful. Because if time can fold, then perhaps beginnings and endings are illusions. Perhaps every loss, every farewell, is merely a crossing through a hidden curve of existence. As the heartbeat fades, the rain continues to rise. The world resumes its motion, unaware of the fracture that just passed through its fabric. For now, time flows as we remember it, forward, steady, dependable. But somewhere in the quiet machinery of the cosmos, a crease has formed. The first fold has been made. The story has already ended, and yet it has just begun. They call it the arrow of time, a simple phrase for something that defines every breath we take. We feel its pull in the melting of ice, the aging of our faces, the way smoke drifts but never undrifts. It is the rhythm of existence, unrelenting, irreversible, the quiet ticking beneath every heartbeat. We rarely question it because it feels so absolute. Yet beneath that familiar flow lies a question that refuses to die. Why does time move forward at all? The answer, or at least the illusion of one, begins with entropy. Entropy is the measure of disorder, the tendency of things to move from order to chaos, from structure to decay. A glass shatters but never reassembles. Heat spreads out, never spontaneously gathers. It is entropy that gives direction to the arrow of time. It is the reason why we remember the past but not the future. Every second that passes leaves the universe a little more scattered, a little less organized. But this law, so fundamental, hides a paradox. The equations that describe our universe, from Newton's motion to Einstein's relativity, don't actually require time to move forward. They work just as well backward. Nature's laws are indifferent. It is we who insist on direction. Imagine watching a film reel in reverse. A drop of ink unspills from water, a broken vase reforms, a flame leaps back into the match. The universe doesn't object to these events in theory, its mathematics allow for them, but reality as we experience it never does. Somewhere between theory and perception, time has chosen a side. What? Scientists call this the problem of the arrow. The universe began, as far as we know, in a state of extraordinary order, dense, smooth, and simple. The Big Bang was not chaos, it was near-perfect symmetry. From that moment forward, entropy has been rising, pushing everything toward complexity and disorder. This rising entropy gives us our sense of progression. But if that's true, then the direction of time is not written into the laws of physics. It's written into the initial conditions of the universe itself. Time moves forward because the universe started simple and keeps getting messy. But this explanation leaves us uneasy. It suggests that time is not an intrinsic property of reality, but a side effect of a cosmic accident, an imbalance left over from creation. The arrow we call destiny might simply be debris from the universe's birth. For philosophers, this raises a deeper terror. If time's direction is contingent, not necessary, then could it one day reverse? Could entropy reach its maximum and begin to fall? Could the arrow of time, our arrow, bend? The thought seems absurd. We have never seen ice unmelt, never seen death reverse into birth. Yet the universe is vast, and our brief human scale may blind us. At the heart of galaxies, near the edge of black holes, gravity crushes matter and spacetime into forms we cannot imagine. There, time itself begins to slow, to stretch, to tremble. What if, under such pressure, the arrow falters? Einstein once described time as a stubborn illusion, but a persistent one. In his universe, the past, present, and future all coexist in a grand, frozen block of spacetime. What we call now is just a slice of a much larger whole. But our minds can only perceive one slice at a time, moving in a single direction. Entropy may be the symptom of that perception, not its cause. To us, time feels like motion, a steady forward march. But what if it's our consciousness doing the marching, scanning through moments that already exist? Each memory, each decision, may simply be a point along a pre-written structure, revealed one frame at a time. We feel the flow, but perhaps nothing truly flows at all. Still, there is something undeniably emotional about the arrow's direction. It gives meaning to life, to change, to growth. Without it, there would be no story, no progress, no evolution. The arrow of time turns chaos into narrative. It gives tragedy its weight and joy its fleeting beauty. A world without forward motion would be unbearable, frozen in eternal symmetry. Yet even as we cling to this comforting current, physics whispers its rebellion. The fundamental laws care nothing for our experience. They describe a reality where time's direction is optional, where the difference between before and after is an illusion projected by entropy and memory. Somewhere beneath the ticking clock, time is not an arrow, it is a sea, calm and boundless, through which the universe drifts in all directions at once. And so the arrow that shouldn't bend continues its flight, fragile and magnificent. Every moment we live, every heartbeat that separates past from future, depends on its persistence. But if the arrow were ever to bend, if the current ever reversed, then all we know would unravel. Cause and effect would collapse. The river of time would turn upon itself, and we would find ourselves staring not forward, but inward at the reflection of eternity. In the early 20th century, a quiet clerk working in a patent office in Bern sat by a window, watching trains pass in the distance. He was 26 years old, his name was Albert Einstein, and he was about to break the world open. Outside, the world moved according to Newton, a universe of straight lines, fixed clocks, and absolute time. Inside Einstein's mind, something began to bend. He imagined light beams and speeding trains, clocks ticking on distant stations, and the strange thought that time itself might not be the same for everyone watching. It was not a mathematical problem at first, but a dream that time could stretch, slow, or twist depending on one's motion through the cosmos. From that dream came the theory of relativity, and with it, the beginning of a new understanding. Time is not separate from space. The two are intertwined, fused into a single, malleable entity called spacetime. Every moment, every position, every event that has ever occurred or will occur is a point in this four-dimensional fabric. What we call gravity is not a force pulling objects downward, but the curvature of that fabric around mass and energy. The sun does not hold the Earth in orbit by tugging at it invisibly, it bends spacetime and Earth simply follows the curve. To grasp this, picture a vast sheet of rubber stretched tight. Place a heavy ball in the center. It sinks, distorting the surface around it. Now roll a smaller ball nearby. It circles the heavier one not because of a string or a pull, but because the surface itself is curved. This is gravity, and it is also time. Every massive object, every star, every planet, every person bends the fabric of spacetime, creating ripples that travel through the universe. Where there is curvature, there is time dilation, the slowing down of time itself. Einstein's insight shattered the illusion of a universal now. Two observers, moving differently or standing in different gravitational fields, do not agree on what is simultaneous. To one, an event has already happened, to another, it is yet to come. There is no cosmic clock synchronizing the universe. Time is relative, elastic, fluid, a dimension that flexes and folds depending on where you stand and how fast you move. This realization carries unsettling implications. If time can stretch, can it also tear? If it can slow, can it stop? Imagine standing near a black hole, that monstrous distortion of spacetime where gravity grows infinite. As you approach its edge, the event horizon, time begins to crawl. A second for you becomes years, centuries for an observer far away. Light itself bends back toward the abyss, unable to escape. To those watching from a distance, you would appear frozen forever at the edge, suspended in time. To you, however, nothing seems to change. You cross the threshold and the universe collapses inward. Inside, time no longer flows from past to future. It becomes directionless, swirling like water down a drain. If we could somehow peer inside a black hole, we might witness time itself being shredded. Moments compressed, futures and pasts tangled into a singular point. Einstein's equations predicted such singularities, but he doubted their existence. To him, they seemed like an imperfection in mathematics, not a reality of nature. Yet decades later, astrophysicists would confirm that black holes are not only real but common. And within their event horizons, the laws of physics break down entirely. The arrow of time loses meaning. What began as a bend becomes a fold, and what was once continuous becomes something else entirely. Einstein's playground was not just a place of equations, it was a realm of imagination. He once said, "Imagination is more important than knowledge," and relativity proved him right. To see spacetime, one must think in pictures beyond the ordinary. A clock racing around the Earth ticks slower than one at rest. Light from distant galaxies stretches as the universe expands, carrying the memory of its journey. Even the act of standing on the ground means you are moving through time slightly slower than someone on a mountain peak, because gravity itself tugs at your seconds. Each of us lives at a different pace, invisible but real. Time, the most personal thing we experience, is not the same for anyone. And yet, relativity did more than warp physics. It warped philosophy. If past and future are both part of the same spacetime structure, then they must both exist. The past does not vanish and the future is not empty. Everything that will ever happen already resides somewhere in the four-dimensional block. We are simply travelers along one path through it, believing in a flow that might not exist. The universe, from this view, is timeless. All events coexist eternally. The flow of time is an illusion born from consciousness moving through the coordinates of spacetime. This concept, sometimes called the block universe, is both awe-inspiring and terrifying. It means that from a cosmic perspective, everything is already written. The birth of stars, the rise of civilizations, the fall of worlds, your first love, your final breath, all are woven into the same eternal fabric. Free will becomes a question mark, destiny becomes geometry, and change itself becomes perception. We are patterns of motion across spacetime, and time's arrow is merely the direction of our awareness tracing those patterns. Einstein resisted mysticism, but his equations spoke in poetry. They described a cosmos where time is not a ruler but a landscape, not something we pass through but something that enfolds us. To stand in the shadow of a mountain or gaze at the night sky is to feel that curvature subtly, to sense the great bending of space and seconds all around. We are creatures swimming through a cosmic sea, unaware that the water itself is moving with us, shaping our every motion. And still, relativity is not the end. Einstein's beautiful geometry begins to tremble under the microscope of quantum mechanics. At the smallest scales, time refuses to behave. Particles seem to know about events before they happen. Quantum entanglement connects distant objects instantaneously, ignoring relativity's cosmic speed limit. Einstein, ever the skeptic, called it spooky action at a distance, but experiments have proven it real. His playground, though vast, was not infinite. Beyond its boundaries, another layer of mystery awaits. Yet his legacy endures, not only in science but in the way we imagine reality. Relativity changed more than equations. It changed our sense of self. It told us that time is not the ticking of a clock, but the dance of matter and energy across an invisible surface. It told us that gravity is not a force but a curvature, and that our lives are curved with it. Every moment we live, every choice we make, is a small distortion in the cosmic fabric, a tiny ripple in the same ocean that carries stars. In the silence between seconds, Einstein's insight still hums. The universe bends, and with it, time. What we once thought was linear has become circular, elastic, alive. Somewhere, light continues to stretch across the cosmos, bending around unseen masses, whispering the same truth in every wavelength. Time is not a straight path. It is a playground of curves, folds, and horizons, a stage upon which the universe performs the illusion of motion. And in the shadows of that stage, we stand in awe, caught between wonder and comprehension, realizing that the line we call time was never straight at all. Somewhere between thought and reality, a quiet boundary exists. A line so subtle that we rarely notice it, and yet it defines everything we call time. The physicists call it the observer's frame of reference. Philosophers call it the mind. Whatever name we give it, it is the point from which the universe begins to make sense, and perhaps the point where time itself is born. Imagine this: a single event, a flash of lightning across a dark plain. Two observers watch from different distances. For one, the lightning strikes before the thunder. For the other, both arrive together. Relativity tells us that both are correct. There is no universal now. Time does not tick the same for all. But that realization leads to a deeper, stranger question. If every observer experiences their own time, does time exist at all without an observer? What if time is not an external thing flowing past us, but something our minds create as they move through experience? What if the forward march of seconds is not an objective truth, but a story our brains tell to connect what would otherwise be chaos, a sequence of frozen moments? The observer's trap begins here. We are creatures built to experience time as motion, yet every bit of evidence hints that motion may be an illusion. Close your eyes and recall your earliest memory. Perhaps it is fragmented. The smell of rain, the sound of laughter, the color of light spilling through a window. That moment feels distant, but it still exists in you, alive in neurons firing as you remember. The present is built from the reconstruction of the past. The brain does not live in now. It lives milliseconds behind, constantly stitching reality together from memory. By the time you believe something has just happened, it already has. This tiny delay, this imperceptible lag between perception and awareness, may be the birthplace of time as we know it. Consciousness may not be moving through time, it may be generating it. Each moment is not a bead on a string, but a frame assembled from fragments of sensory data and memory, giving the illusion of flow. Time may be the brain's way of organizing change, not the universe's. In physics, the observer plays an unsettling role. Quantum mechanics teaches us that until something is observed, it exists in a state of superposition, both here and there, both past and future. Observation collapses the possibilities into a single outcome. Does this collapse happen in the mind, or in the physical act of measurement? The debate has raged for decades. Some say consciousness is irrelevant, that detectors alone suffice. Others whisper that awareness itself is the missing ingredient, that reality does not fully exist without being experienced. If that is true, then the observer is not a passive spectator but a participant, shaping the very fabric of time with attention. The moment we observe, we define a sequence. Before we look, there is only potential. No past, no future, no order. Perhaps time, then, is not a pre-existing river we step into, but the wake left behind as we move through consciousness. Philosophy has circled this paradox for centuries. Augustine once wrote, "What then is time? If no one asks me, I know. If I wish to explain it, I do not." For him, the past was memory, the future expectation, and the present, the brief instant of perception, was the only thing that truly existed, and yet vanished as soon as it appeared. Modern neuroscience echoes this idea. The now we experience is not a single moment but a small window, perhaps 3 seconds wide, that the brain uses to assemble continuity. Our sense of time passing is an illusion created by stitching together countless flickering frames of awareness. But this realization carries an existential weight. If time is a construct of the mind, then the boundary between internal and external reality begins to dissolve. The tick of a clock, the orbit of a planet, the decay of an atom, all these may be expressions of a deeper order, one that only takes shape through observation. Without us, would time still unfold? Or would the universe remain suspended in a silent equilibrium, waiting to be perceived? Consider the act of dreaming. In dreams, time behaves differently. Minutes stretch into hours, hours collapse into seconds. Events unfold without sequence or logic, yet they feel real. You might live a lifetime in a dream, only to wake and discover that a few moments have passed. If time can expand and contract within the mind so effortlessly, how much of waking time is just another kind of dream, a shared hallucination grounded by the rules of collective perception? This is the observer's trap. We cannot escape the lens through which we view reality. We can study time with equations, measure it with atomic precision, and yet every measurement loops back to us. The act of observing becomes inseparable from what is observed. In the deepest sense, we are trapped inside the machinery of our own awareness, confusing the rhythm of thought for the rhythm of the universe. There is, however, another possibility, that consciousness and time are not separate things but two sides of the same fold. As awareness arises, it creates the sensation of motion. As motion unfolds, it deepens awareness. The universe may not be evolving in time, it may be experiencing itself through the structure of consciousness. Just as a wave and the sea are not distinct, time and the observer may be inseparable. When mystics speak of timelessness, the stillness beyond past and future, they may be describing what happens when this illusion collapses. In deep meditation, in near-death experiences, in moments of awe or terror, people report a sensation of time stopping. What they describe is not emptiness but fullness, an overwhelming sense that all moments exist simultaneously. In that instant, the observer steps outside the trap. The mind ceases to separate before from after, and experiences reality in its totality, as a single, continuous presence. Science, too, hints at this possibility. The equations of relativity, the probabilistic haze of quantum fields, the entropic arrow, all these can be viewed not as movements through time, but as manifestations of information being observed. The universe may be a computation, and consciousness the interface through which it renders. Time could be nothing more than the refreshing rate of that cosmic simulation, a flicker so fast we mistake it for continuity. But there is something haunting about this thought. If time depends on observation, what happens when there are no observers left? When the stars burn out, when entropy reaches its maximum and the cosmos falls silent, will time end, or will it simply stop being measured? Perhaps time will fold back into its source, like a thought forgotten, waiting to be remembered again. And yet, within this trap lies freedom. If time is born in perception, then every instant is infinitely rich. The past and future may be illusions, but the present, the awareness of being, becomes sacred. To live fully in the now is to stand at the edge of creation, to witness the universe forming itself from moment to moment. Every breath becomes a beginning. Every thought, a universe unfolding. In the end, the observer's trap is not a prison, but a mirror. We gaze into it, searching for time, and find ourselves staring back. Perhaps the universe needed eyes to see itself, minds to give meaning to motion, and memory to make sense of change. Perhaps consciousness is not a byproduct of time, but its author. And if that is true, then time does not exist without us. It waits for us to awaken, to look, to feel, to name the moment. Down at the smallest scale of existence, beneath the atoms, beneath the swirl of protons and electrons, the fabric of reality begins to whisper a different language. Here, in the quantum realm, the smooth lines of Einstein's spacetime begin to dissolve into probabilities, uncertainties, and ghosts of possibilities that defy all intuition. It is a realm where the rules of cause and effect, the very bones of time, no longer seem to apply. Imagine looking at an electron, not as a solid point, but as a mist of potential, a shimmering cloud of maybes. It exists here and there, moving forward and backward in time, occupying several states at once. Only when we measure it, only when we look, does it decide where it has been. The act of observation doesn't just reveal reality, it seems to create it. That simple, haunting idea lies at the heart of quantum mechanics, and it shatters everything we thought we knew about time. This is the betrayal, the moment the quantum world turns against the classical one. The universe we thought we understood, governed by predictability and order, begins to unravel into strangeness. The arrow of time, so confident and linear, flickers like a candle in a storm. In the laboratory, physicists send single photons through a pair of slits and watch as they interfere with themselves, forming patterns that shouldn't exist. Each photon behaves as if it has traveled through both paths simultaneously, as though it has explored the future and the past before deciding how to arrive. When detectors are placed to see which slit it passes through, the interference disappears. The photon chooses one path as if it knows it's being watched. The implication is unsettling. Reality doesn't commit to a single history until it is observed. Until that moment, all possible histories coexist. Time, instead of being a straight line, becomes a tangle of probabilities, a shimmering network of maybes branching endlessly in every direction. At first, scientists resisted this idea. Einstein himself refused to accept it. God does not play dice with the universe, he said, convinced that some hidden law must restore order. But the dice kept rolling, and experiment after experiment confirmed the chaos. The quantum world was not only strange, it was consistent in its strangeness. One of the strangest of all was the delayed choice experiment. In this setup, a photon is sent through a device where it can take two paths. But scientists delay the decision of whether to measure its path until after it should have already chosen one. The results are impossible. The photon seems to retroactively decide its behavior. It acts as if it knows what will happen in the future, as if the future is somehow shaping the past. What does that mean? It means causality, the sacred law that cause comes before effect, may not be as sacred as we think. It means that the present may depend on the future just as much as on the past. It means that time, at the most fundamental level, might not flow at all. Instead, it might loop, reflect, or collapse into patterns we cannot yet comprehend. Imagine for a moment a universe where cause and effect trade places, where the outcome of an experiment determines its origin, where a particle's decay creates its own trigger. The quantum realm does not forbid this. In fact, it may demand it. Some physicists have begun to speculate that time's direction emerges only when large numbers of particles interact. That at the deepest level, the universe is time-symmetric, indifferent to direction. If that is true, then the arrow of time, the forward march of entropy, is a macroscopic illusion, a collective hallucination of complexity. The universe at its root might be timeless. Each quantum event might simply be, not happening in sequence, but existing all at once in a vast, interconnected pattern. This vision of timelessness is not just mathematical, it is existential. It means that our experience of before and after may be a projection of consciousness, a way for our minds to navigate the quantum web. We see causality because we need it to make sense of change, but the underlying reality may be closer to a tapestry without order, woven from threads that shimmer both ways. And then there is entanglement, perhaps the most astonishing betrayal of all. Two particles, once connected, remain linked across any distance. Measure one, and the other instantly reflects the result, even if separated by galaxies. The connection is immediate, defying relativity's cosmic speed limit. To Einstein, it was spooky action at a distance. To us, it may be the fingerprint of a deeper truth, that space and time themselves are not fundamental but emergent. If entangled particles can communicate outside time, perhaps they are not communicating at all, perhaps they are still one entity, existing in a realm where distance and sequence do not apply. Entanglement could be the echo of unity glimpsed through the cracks of reality, a sign that the universe is not divided into then and now, but exists as a single, undivided whole. Some theories go even further. The Wheeler-Feynman absorber theory suggests that particles exchange signals both forward and backward in time. Every photon emitted might send one wave into the future and another into the past, meeting somewhere in the middle to create what we call the present. Time, in this view, is a handshake, a negotiation between what has been and what will be. If the future can influence the past, then the concept of destiny takes on new meaning. Perhaps we are not simply moving forward through an unfolding timeline, perhaps we are also being pulled toward a fixed future, drawn by the gravity of events that already exist. The past pushes us, but the future calls to us, shaping our path from both ends. It is an idea that blurs the boundary between physics and philosophy, between science and myth. The ancients spoke of fate as a web, an invisible structure binding all events together. Quantum physics, in its own way, tells the same story, only its threads are particles and its loom is time itself. But this betrayal of time also carries hope. If causality is flexible, if the future can influence the past, then the universe may be more interconnected than we ever imagined. It may mean that consciousness, choice, and intention ripple backward as well as forward, that meaning itself is part of the cosmic equation. Perhaps our awareness doesn't merely ride the wave of time but helps to shape it. Yet there is danger in this thought too. The human mind, built to perceive sequence, trembles at the idea of reversal. If the future is already written, are we free? If the present is shaped by what has not yet occurred, how can we act at all? The quantum betrayal does not comfort us, it disorients us. It forces us to face the possibility that the universe is not unfolding, but already complete, and that we are travelers inside a structure so intricate that our sense of motion is only the illusion of discovery. In the stillness of the quantum world, there is no past, no future, only potential. Time does not pass there, it hovers, suspended like dust in sunlight. Every possibility glows with equal weight, waiting for observation, waiting for choice. When we look, one thread brightens and the others fade, and in that act the universe takes shape. The betrayal of time is complete, and the illusion begins anew. Perhaps the greatest mystery of all is that we are aware of it. The universe watches itself through us, experiencing its own uncertainty. Every thought, every observation, every act of wonder is the cosmos recognizing itself across the boundary of time. And maybe that is what time truly is. Not a direction, not an arrow, but the heartbeat of awareness echoing through a sea of possibilities. In the silence between those echoes, everything waits. The universe is not becoming. It already is. In the deepest corners of cosmological thought, where science and speculation blur into one another, there exists a question so strange that it feels like a mirror held up to the universe itself. What if time doesn't only move forward in our cosmos? What if, somewhere beyond the reach of light, there is another universe where time flows backward? A mirror world, born in the same instant as ours, expanding in the opposite direction, its stars growing younger as ours grow old, its entropy falling as ours rises. A universe in reverse. It sounds like fiction, the kind of poetic symmetry the human mind invents to comfort itself. But the equations of physics, as indifferent as they are elegant, quietly allow it. The fundamental laws that govern our reality, Newton's, Maxwell's, Einstein's, do not forbid time from running backward. They describe motion, energy, and gravity equally well in both directions. The universe itself seems to care little for the arrow of time. Only entropy, the slow drift from order to chaos, gives our world its sense of forward motion. And if entropy can increase here, what prevents it from decreasing elsewhere? To imagine this mirror universe, we must return to the beginning, to the moment of the Big Bang. Not an explosion in space, but an explosion of space. A single point of infinite density and energy unfolding into everything we know. For reasons no one fully understands, our universe began in a state of extraordinarily low entropy, astonishingly ordered, smooth, and balanced. That order has been decaying ever since, giving rise to the passage of time as we experience it. But what if, in that same birth, on the other side of the singularity, another cosmos was born, identical in its beginning but inverted in its flow? Picture two universes like twin waves rippling outward from the same point of origin. To one, time moves forward, to the other, backward. Each perceives itself as normal, with the other seemingly trapped in reverse. Both exist within the same grand symmetry, two halves of a single whole, expanding into their respective futures, or perhaps into their respective past. This is the essence of the mirror universe hypothesis, proposed not by mystics but by physicists. It is the idea that our universe may not be alone but paired, a cosmic reflection whose time arrow runs in the opposite direction. And if that is true, then the Big Bang wasn't just a beginning, it was also an intersection, a point where two times touched, then diverged. What would such a world look like? In our mirror counterpart, decay would reverse. Broken things would mend. Ashes would gather and ignite into wood. The dead would rise, not from miracle, but from natural law. Stars would absorb their light instead of emitting it. Galaxies would spin inward, collapsing into density until one day, at what we would call their birth, they vanish into a single luminous seed. The inhabitants of that world, if any existed, would not experience their reality as backward. To them, entropy would still increase, clocks would still tick forward, memories would still accumulate. Their perception would make their time normal, just as ours feels normal to us. It is only from the outside that we see the reversal. This symmetry is not just poetic, it may be necessary. The equations of physics demand balance. For every positive, a negative. For every action, an equal reaction. Perhaps the universe itself obeys this deeper balance, creating its reflection at birth to conserve the grand total of time and entropy. Ours expands one way, the other expands in reverse. Together they form a perfect zero, a cosmic equation satisfied. The implications are staggering. It means that everything we call the past might be mirrored by another universe's future. When we look back toward the Big Bang, we see light traveling from the dawn of time. But from the other side, that same light could be the future shining backward. To them, we would be the mirror, a strange universe aging in reverse, moving away from the same beginning. At the edge of this idea lies something even more profound, the possibility that consciousness itself may be connected across the fold. If the two universes are entangled, their histories might influence each other in subtle ways. What we perceive as chance, quantum fluctuations, the birth of galaxies, even the origin of life, could be the faint echo of decisions or patterns made in that mirrored cosmos. Our time might not just run parallel to theirs, it might be woven with it, threads of causality looping through the fold between them. Some theories in quantum cosmology, like the CPT symmetric universe model, suggest precisely this. CPT, charge, parity, and time reversal, is a fundamental symmetry of nature. If you flip the charge of all particles, invert their spatial coordinates, and reverse time, the laws of physics remain identical. A mirror universe obeying the opposite direction of time would be the natural completion of this symmetry. Its matter would be antimatter to ours, its time inverted, but its physics the same. In this view, we are not two separate realities but one grand structure, reflected across the mirror of time. This reflection gives rise to strange philosophical questions. If both universes began together, where does beginning truly reside? Is the Big Bang the midpoint between two eternities? Perhaps what we call the beginning is neither start nor end, but the moment of perfect symmetry, the instant when both arrows of time were born pointing away from each other. The universe we see expanding outward may not be heading toward its end, but toward its reflection. Such an image is haunting. Two vast realities, racing away from the same event, never able to meet, yet forever connected by the silent memory of their birth. It is as though the cosmos split itself in two to see its own face, one half aging, the other rejuvenating, both tracing the same cosmic breath. And what would it mean for us, the observers trapped inside one side of the mirror? Could we ever detect this twin? Perhaps only indirectly, through the faint imbalance between matter and antimatter, through subtle violations of symmetry that reveal the echo of the other side. Some scientists propose that dark matter, the invisible substance that shapes galaxies, could be matter from the mirror universe leaking through the fold. We cannot see it because its arrow of time runs opposite to ours. It drifts like a ghost through our cosmos, untouchable yet gravitationally real. But there is a deeper, quieter implication, a philosophical mirror as well as a physical one. If such symmetry exists, then perhaps everything in our world has a reflection across that divide. Every moment, every event, every life. Perhaps there is another version of you, not identical but inverted, walking the same road in reverse, unmaking the choices you have yet to make. The idea is unsettling but also strangely beautiful. It means that nothing is ever lost, only mirrored. Every collapse here is a creation there, every ending a beginning in reverse. In this view, death itself becomes a kind of symmetry. The decay of matter, the fading of energy, all may simply be transformations seen from one side of time's reflection. On the other side, life would be the return, the unwinding of complexity back into order. The two universes breathe in harmony, one exhaling what the other inhales. If we could stand outside both, if we could step into the place between them, we might see the entire symmetry at once. Two vast tapestries unfurling from a single thread, their patterns moving in opposite directions, their destinies intertwined. That midpoint, where time folds upon itself, would be neither future nor past, only pure existence, beyond sequence, beyond decay. Perhaps that is what eternity truly means, not endless time but the end of direction. And maybe, just maybe, that is where all consciousness ultimately returns, not to oblivion but to the mirror's edge where every beginning meets its reflection. In that silent, boundless symmetry, the universe gazes at itself. One side calls it creation, the other calls it return. We, standing within one half, can only sense the faint echo of the other, the pull of a mirrored heartbeat deep beneath the surface of time. The universe may not be a story moving forward, but a conversation between reflections, forever speaking across the fold. Imagine standing at the edge of everything, not space, not distance, but the boundary between what was and what will be. There, in the silence beyond the galaxies, the fabric of spacetime curves back upon itself, as if the cosmos were preparing to breathe inward. The expansion that began with the Big Bang continues to stretch reality thinner and colder, but hidden within the equations of cosmology lies a whisper, an unsettling symmetry. What if this outward motion is not eternal? What if the universe, in its final act, folds back toward itself, collapsing time, memory, and matter into a single impossible instant? This is the mystery of the folding cosmos, the idea that the universe may not simply expand forever, but will one day recoil, reversing the arrow of time in a slow, magnificent implosion. To understand it, we must first return to the rhythm of cosmic evolution. The Big Bang was not an explosion into empty space but the expansion of space itself, carrying galaxies with it like dust on an inflating balloon. For billions of years, that expansion has continued, driven by an unseen energy, dark energy, that pushes galaxies apart faster and faster. Yet, this accelerating expansion poses a paradox. The universe, as far as we can observe, is racing toward isolation. Galaxies will drift beyond sight, stars will fade, and even atoms may decay. Time in that desolate future will lose its meaning. Entropy will reach its maximum, and no change will remain possible. That is the so-called heat death, a frozen eternity. But not all theories accept this quiet ending. Some suggest that the acceleration may one day slow, stop, and reverse, as if dark energy itself were a temporary phase, destined to fade or transform. When that happens, the universe could begin its great contraction, a process that mirrors the Big Bang in reverse. Physicists call it the Big Crunch. It is a scenario both terrifying and beautiful. Space would begin to shrink, drawing galaxies back toward each other. Stars, long dead, would reignite as their remnants collide in waves of unimaginable energy. Black holes would merge, tearing through the collapsing fabric like wounds of gravity. The temperature of the cosmos would rise, reversing billions of years of cooling. Time itself, our most faithful companion, would begin to twist. But what does it mean for time to reverse? In a contracting universe, entropy could begin to decrease, not because the laws of physics change, but because the direction of the universe's evolution does. From our perspective, everything would appear to move backward. Cause and effect blending, decay transforming into creation, disorder collapsing back into perfect order. The cosmos would retrace its own steps. Every galaxy, every particle, every heartbeat would fold inward toward the singularity that birthed it. Some cosmologists believe this could be the ultimate expression of symmetry. The Big Bang and the Big Crunch would not be separate events but two ends of the same loop. The universe, in its totality, might be cyclic, eternally expanding and contracting, breathing in and out across eons. Time in such a model would not be a line but a circle, forever folding inward, erasing its own history to begin anew. To visualize this, imagine a vast cosmic pendulum. At one end, infinite density, the singularity of the Big Bang. At the other, infinite emptiness, the heat death. The pendulum swings from one extreme to the other, but at its turning point, at the moment of perfect stillness, time as we know it ceases to exist. In that moment, the universe might reset. The Big Crunch could become the next Big Bang, the destruction of one era feeding the creation of another. And if the laws of physics are truly time-symmetric, then what we perceive as the end could be someone else's beginning. The collapse of our universe might give birth to another, expanding outward in the opposite direction, its arrow of time reversed relative to ours. To us, it would look like a rebirth. To them, it would look like an origin. Two universes, mirror reflections, passing through each other at the moment of creation. The folding cosmos, then, is not just a vision of destruction but of unity. It suggests that everything we have ever known, stars, life, consciousness, is part of a single pulse, eternally repeating. Time itself may not flow endlessly forward but may be a wave oscillating through creation and collapse, through order and chaos. Each cycle would carry echoes of the last, faint imprints written into the fabric of spacetime, patterns that might one day be recognized as cosmic memory. But within that beauty lies something deeply unsettling. If time can reverse, what happens to identity? To memory? To meaning? Would we live our lives again backward, remembering the future, forgetting the past? Or would all awareness dissolve at the fold, erased as the universe resets its clock? It is a question that blurs the line between physics and metaphysics, between observation and existence. Perhaps consciousness, too, follows the rhythm of the cosmos, emerging with expansion, dissolving with collapse, only to arise again in the next cycle, unaware of the eternity behind it. If so, we may not simply die with the universe, we may return with it, reborn in the next unfolding of time. The collapse is not an ending but a transformation, a renewal of the cosmic breath. This cyclical vision has deep roots. Ancient mythologies across the world spoke of cosmic cycles, ages of creation and destruction, of worlds rising and falling in endless recurrence. The Hindu concept of kalpas, the Stoic idea of eternal return, even certain interpretations of the Mayan calendar, all echo the same truth modern cosmology is rediscovering, that time might be a loop, not a line. That what dies is what will live again. Modern physics gives this myth a mathematical backbone. Quantum gravity, still in its infancy, hints that the singularity at the heart of a black hole might not be a point of infinite destruction, but a bridge, a transition to another region of spacetime. If the universe itself behaves like a cosmic black hole, then its collapse could lead not to annihilation but to transformation. The death of one cosmos could ignite the birth of another. Time would fold, and from that fold, creation would bloom anew. Yet, in this infinite recurrence, something profound emerges, a sense of belonging. The atoms in our bodies, the light in our eyes, the thoughts that rise and fade, all are temporary arrangements of the same timeless matter, playing their role in an endless symphony of becoming and returning. Every life, every civilization, every star is a note in the cosmic song that never truly ends, only changes its rhythm. And if this is true, then perhaps the universe is not a tragedy of decay but a masterpiece of renewal. The folding inward of time is not a collapse but a gesture, the universe bowing to itself, preparing to rise again. The Big Crunch becomes a kind of cosmic heartbeat and we are its pulse. Even now, as we look into the night sky, we may be seeing both directions of time at once, the fading light of the past and the first whisper of what comes next. In that vastness, there is a hidden symmetry, a quiet promise that no end is final. The universe folds inward, yes, but not to vanish, to remember, to begin again. And so, the folding cosmos is both mirror and bridge. It is the place where the laws of physics become poetry, where the language of entropy meets the music of eternity. In that final, luminous collapse, time will no longer pass. It will breathe, and through that breath the universe will be born once more. Deep in the fabric of existence, beyond what telescopes can see or equations can easily express, there may exist structures that do not simply lie within time, they shape it. These are the cosmic architects, the silent engineers of reality, black holes. They are not merely collapsed stars or points of gravitational fury. They are boundaries, thresholds between what can exist and what cannot. To look into a black hole is to gaze into the engine room of spacetime itself, where gravity crushes matter, warps geometry, and bends the arrow of time until it folds back on itself. At first, black holes were theoretical curiosities, mathematical consequences of Einstein's equations. A star massive enough, collapsing under its own gravity, would become so dense that not even light could escape its grip. This invisible monster would distort space around it, creating a region from which no information could return. For decades, physicists regarded them as exotic oddities, mere artifacts of theory. But then we found them, first indirectly through their gravitational pull and then directly through the Event Horizon Telescope's haunting image, a glowing ring of light encircling absolute darkness. What that image shows is not an object but a boundary, the event horizon, the surface beyond which all paths lead inward. It marks the point where space and time trade places. Inside the horizon, all directions in space, including forward, point toward the singularity. Time, too, is dragged into this descent. It no longer flows as we experience it, it collapses, funneling all moments toward a single timeless end. The black hole is not simply a pit in space, it is a well in time. Einstein's equations predict that once matter crosses this horizon, it is lost forever. But quantum theory resists such finality. Information, according to quantum mechanics, can never be destroyed, it can only change form. Here, at this cosmic border, the two greatest theories of physics clash. Relativity sees inevitability, quantum mechanics demands preservation. Out of this tension arises one of the greatest puzzles of modern science, the information paradox. Stephen Hawking's groundbreaking work in the 1970s revealed that black holes are not completely black. Through quantum effects near the event horizon, they emit faint radiation, now known as Hawking radiation, and over time this causes them to shrink and eventually evaporate. But as they vanish, what happens to the information that fell inside? If it is truly lost, then the laws of physics break. If it survives, how does it escape a place where escape is impossible? The answer may hold the key to the nature of time itself. Some physicists suggest that the information isn't lost at all, that it is encoded on the surface of the event horizon, like data stored on a cosmic hologram. The black hole becomes not a void, but a vault, preserving every particle, every quantum fluctuation, every moment that crossed its boundary. From this idea grew the holographic principle, the astonishing proposal that our entire universe might function the same way. That everything we see and experience, every moment of time, is a projection from information inscribed on the boundary of reality. In such a universe, space and time are not fundamental. They are emergent, like a three-dimensional film playing out from a two-dimensional screen. If the holographic principle is true, then black holes are not destroyers but creators, the primordial forges where spacetime is written and rewritten. The singularity, rather than an end, might be the seed of new beginnings, where the laws of physics themselves are reassembled. Some theories propose that the core of a black hole could birth a new universe, a bubble of spacetime budding off from ours, expanding with its own arrow of time. In this sense, every black hole might be a gateway, a womb of creation. Our own universe, perhaps, could be the offspring of another, born from the collapse of an ancient cosmos. But beyond the equations there is a deeper, more unsettling dimension. Inside a black hole, time itself loses its meaning. The singularity is not merely a point in space, it is a place where the past and future dissolve. Once inside, everything, matter, energy, even causality, converges. There is no before or after, only the infinite compression of all existence into a single timeless instant. The black hole in this way becomes a paradox, a region where time ends and yet, perhaps, where new time begins. Imagine for a moment falling into one. To an outside observer, you would appear frozen at the edge, your image stretched and redshifted until it faded into darkness. But from your own perspective, you would cross the horizon effortlessly, never noticing the divide. As you fall, the universe outside would seem to accelerate. Stars would age in seconds, galaxies would bloom and die. The entire future of the cosmos would play out before your eyes in a final, endless moment. Time as you knew it would collapse into eternity. And then, perhaps, the collapse would reverse. The black hole's singularity might not be destruction, but transformation. Some models of quantum gravity suggest that as matter compresses to extreme density, it reaches a point where spacetime rebounds. Instead of ending, it tunnels through to another region of reality, a white hole, the mirror opposite of a black hole, where nothing can enter, only escape. To the other side, your fall would look like a burst of creation, a new Big Bang igniting from the ashes of collapse. This vision binds the smallest and largest scales of existence. Each black hole becomes a bridge, connecting death and birth, end and beginning, entropy and renewal. The collapse of time in one region could be the expansion of time in another. The universe, through these dark mirrors, may perpetually fold itself, transferring information and energy across boundaries invisible to us. And if black holes are cosmic folds, then they may also reveal something about the nature of consciousness. Just as information is never truly lost in a black hole, perhaps awareness, too, is not annihilated by time, but encoded, transformed, waiting for another form in which to unfold. In this sense, black holes might not only shape the geometry of the universe but the metaphysics of being itself. Even the image of the black hole, that luminous ring around absolute night, feels like a metaphor for existence. Light endlessly circles the edge, trapped between escape and surrender, between motion and stillness. It is the perfect symbol of time, always moving yet never free from its own gravity. To look at a black hole is to see time eating itself, and yet also time being reborn. There is something hauntingly poetic in the idea that every collapse hides a creation. Every fall into darkness conceals a light struggling to emerge. The black hole, once feared as the ultimate destroyer, becomes the universe's most eloquent expression of transformation, where time, space, and reality converge into one eternal act of folding. Perhaps, then, black holes are not the end of time at all. They are the punctuation marks in the cosmic story, pauses, breaths, transitions. Each one a reminder that even in the deepest silence, the universe is still speaking, still rewriting itself. We, like the light circling those horizons, are caught in that eternal dialogue, witnesses to a universe forever folding inward, and through that folding, forever becoming new. There are moments in human history when discovery feels less like invention and more like remembrance, as if the universe, through us, is trying to remember itself. One such moment came when scientists realized that time, that most sacred and unquestioned current, could be broken, bent, or even erased through the geometry of the cosmos itself. It began not with mystics, but with mathematicians and physicists, tracing the delicate curves of Einstein's equations into places no human mind had dared to follow. There, buried in the mathematics, lay a strange truth: time loops were not impossible. They were permitted, quietly, elegantly, disturbingly, by the very laws of the universe. In ordinary life, time flows like a river, always forward, never repeating. But in Einstein's theory of general relativity, time is not a current, it is a landscape. It can twist, curve, and fold. The presence of massive objects like stars and black holes bends spacetime, slowing clocks and distorting sequence. If enough curvature could be created, through immense gravity, rotation, or exotic matter, time might not simply slow or stretch. It could circle back upon itself. In such a place, a traveler could follow a path through spacetime and return to the same moment from which they departed. A loop not of space but of time. The first to see this possibility was Kurt Gödel, the logician who once dismantled the foundations of mathematics by proving that every logical system is incomplete. In 1949, Gödel presented a solution to Einstein's equations describing a rotating universe. In it, spacetime itself swirled like a cosmic vortex. This rotation, he showed, would allow closed time-like curves, paths through spacetime that loop back in time. In Gödel's universe, time had no direction. The past, present, and future all coexisted, each point connected to itself through the geometry of the cosmos. Einstein himself, though fascinated, found the idea profoundly unsettling. If Gödel's universe were real, then the very notion of temporal sequence, of cause and effect, would collapse. And yet the equations held. There was no mathematical reason the universe could not contain such loops. Over the decades, physicists found other possible configurations. Wormholes connecting distant points in spacetime, cosmic strings stretching through the void, regions around rotating black holes, all capable, at least theoretically, of bending time into a circle. A wormhole, or Einstein-Rosen bridge, is perhaps the most famous. It is a tunnel through spacetime connecting two regions, possibly even two universes. If one mouth of a wormhole were accelerated or placed near a massive object while the other remained stationary, time near each mouth would pass differently. A traveler entering one side could exit the other before they entered. The bridge would not only connect space, it would connect moments, allowing motion across the timeline itself. But such loops raise impossible questions. If you could return to the past, could you change it? Could you prevent your own birth? Meet yourself? Kill your grandfather and erase your own existence? These paradoxes, immortalized in thought experiments and science fiction, reveal the fragile absurdity of tampering with causality. And yet, nature might already have solved the paradox, through consistency. Physicist Igor Novikov proposed that the universe enforces a self-consistency principle. Events along a closed time-like curve must be consistent with one another. In other words, you could travel back in time, but you could not alter the past in a way that creates contradiction. Whatever actions you take in the past were always part of history. Time is not rewritten, it is self-correcting. You are not changing destiny, you are fulfilling it. This concept transforms time travel from fantasy into fatalism. The loops are not opportunities for change, but revelations of inevitability. The future creates the past as much as the past creates the future. Cause and effect dissolve into one another. Time, in this view, is not a flowing river but a frozen sculpture. A structure we move through, experiencing its shape moment by moment, believing it flows only because we cannot see its entirety. But perhaps the most haunting aspect of time loops is not paradox but consciousness. What would it mean to live within a loop, to experience eternity as repetition? Would you remember the previous cycles? Or would awareness reset, forever trapped in a single orbit of perception? Nietzsche once imagined eternal recurrence as a test of the soul, to live one's life again and again eternally with no change, no escape. The idea was meant as a philosophical mirror, a question of whether one could love existence so deeply as to embrace its infinite repetition. Yet, modern physics, with its closed time-like curves and self-consistent loops, brings Nietzsche's vision from metaphor into mathematical possibility. If such loops exist, perhaps they are rare, hidden deep within the cosmic architecture, near black holes or within the rotational heart of the universe. But if they do, then time may not be linear anywhere. The entire cosmos could be threaded with these cycles, subtle feedback loops linking events across eons. Quantum fluctuations could echo through time, their effects rippling both forward and backward. The birth of stars might be influenced by the death of others, in a dance of cause and effect without clear beginning. In this strange, circular reality, we are left to question what it means to move through time at all. The very concept of progression becomes illusory. We are not traveling along a line but rotating within a vast, multidimensional spiral. Every moment, every choice, every heartbeat could already be part of an eternal circuit, repeating endlessly, yet feeling new each time because memory cannot survive the turn. Some physicists even speculate that our universe as a whole might be a closed time-like structure, that the Big Bang and the Big Crunch are not separate events but the same moment seen from different perspectives. If so, then existence itself is a loop, with creation and destruction eternally entwined. The universe doesn't merely age and die, it circles back upon its own birth, replaying the same cosmic story forever, each iteration indistinguishable from the last. But there is an alternative, darker interpretation, that these loops are not perfect circles, but spirals, each cycle slightly different from the last. The universe does not repeat exactly, it evolves, each turn bringing new variations, new possibilities. Time, then, is not an endless repetition but a fractal, self-similar but never identical, infinite yet ever-changing. Within such a structure, perhaps consciousness plays a role. Awareness might be the mechanism by which the universe remembers itself across loops. The echo that carries forward, the thread that binds one iteration to the next. Each life, each experience, might be both unique and familiar, the universe's way of exploring itself through slightly altered versions of the same eternal design. Time loops, then, are more than a curiosity of physics. They are a mirror reflecting the deepest truth of existence, that beginning and end are illusions, that causality is a story told by perception, and that the universe is both author and reader, forever caught in the act of turning its own pages. Imagine, at the end of all things, the cosmos folding back upon its beginning, light tracing the same spiral inward. Perhaps there, in the heart of eternity, we would find not chaos or confusion, but harmony, a perfect symmetry where every event, every life, every heartbeat fits into the grand design of repetition. The loop would close not as a prison but as completion, the universe recognizing itself, finally, for what it has always been, an endless circle of becoming. In that moment, time would not end or begin. It would simply be infinite, recursive, alive. There is a silence that lingers at the edge of every scientific discovery, the quiet before understanding collapses under its own paradox. When the equations of relativity and quantum mechanics are set side by side, their unity fractures, and what emerges is a strange, shimmering boundary where time itself seems to lose meaning. Here, the universe stops behaving like a clockwork system of causes and effects. Instead, it becomes a storm of probabilities, flickering between existence and non-existence, as if reality itself were hesitating. It is in this tension, between certainty and uncertainty, between classical continuity and quantum chaos, that physicists begin to suspect time may not be what we think it is. In the macroscopic world, time feels continuous. A moment leads to the next, forming the tapestry of our experience. But in the quantum world, continuity dissolves. Events don't unfold smoothly, they jump, leap, or blur into one another. Subatomic particles can exist in multiple states at once, occupying contradictory positions until observed. They can even become entangled, their fates bound across distances, as if they share a single instant that transcends the ordinary flow of time. Einstein called it spooky action at a distance, but perhaps it is more accurate to call it spooky action across time. The strangest realization came with the discovery that quantum mechanics doesn't merely describe what happens, it shapes what is allowed to happen. The act of observation or measurement determines reality. In some interpretations, such as the Copenhagen view, the future isn't fixed until it's observed. Possibilities remain fluid until crystallized by awareness. This invites a haunting question. Could our observation in the present reach backward, influencing the past? In a series of thought experiments, physicists like John Wheeler proposed something astonishing, that the present can, in some sense, determine the past. Wheeler's delayed choice experiment demonstrates that how we choose to observe a particle now can retroactively change its behavior before the choice was made. The photon, traveling through space, seems to decide whether it behaved as a wave or a particle only after the observer's decision, even if that decision is made after it has already passed through the experiment. In this way, cause and effect begin to blur. The universe no longer appears as a sequence of events arranged along a timeline, but as a network of relationships, where the past and future continually inform one another. Time, from this perspective, is not a one-way street. It is a dialogue, an ongoing conversation between what was, what is, and what might be. This strange reciprocity leads to even more radical interpretations. The transactional interpretation of quantum mechanics, for instance, envisions particles exchanging handshakes between the past and the future. A particle moving forward in time sends a wave, while another traveling backward responds, forming a completed transaction that constitutes a single event. Reality, then, is not built moment by moment but formed through the resonance of these temporal exchanges. Every event is both a cause and an effect, a bridge across time. If this is true, then the entire universe could be understood as a vast symphony of such handshakes, a timeless web of connections linking all events across the expanse of existence. Time does not flow, it resonates. Every particle, every atom, every cell hums with echoes from both its past and its future. Our experience of now is merely the interference pattern, the place where these waves intersect, forming a momentary illusion of sequence. But the implications stretch beyond physics and into the heart of consciousness. If observation shapes reality, then consciousness, whatever it truly is, may be the anchor that holds the universe together. Perhaps time unfolds not independently but through awareness. The future we anticipate, the memories we hold, may not be passive recollections or expectations, but active components of how reality organizes itself. In quantum mechanics, information is sacred. It cannot be created or destroyed, only transformed. And if the universe is an information system, as many physicists and philosophers now suggest, then time might simply be the mechanism through which information is processed. The arrow of time we experience could be a byproduct of entropy, of information dispersing through the cosmos, not a fundamental aspect of existence itself. Yet there is a paradox at the heart of this picture. The equations that describe the universe at the most fundamental level are time-symmetric. They do not distinguish between past and future. The laws of physics work perfectly well in both directions. It is only we, conscious biological beings, who perceive a difference. Somewhere between the quantum and the cosmic, time acquires direction, and we become trapped in its current. What if that direction is an illusion of scale? On the quantum level, time might flicker back and forth, an undulating sea of reversals. On the human level, these fluctuations average out, creating the illusion of forward motion. Just as countless random molecular motions give rise to the smooth flow of heat, perhaps countless temporal oscillations create the smooth flow of time. Imagine standing outside of time, watching it ripple like water in a pond. Each droplet, each quantum event, distorts the surface, creating ripples that interfere, overlap, and cancel. From within the pond, one might feel those waves as the passage of moments. But from above, from beyond, it would all appear still, a shimmering whole where every disturbance exists simultaneously. This vision of time challenges not only science but the foundation of human identity. If past and future are equally real, then who are we? The self, as we understand it, depends on sequence, on memory and anticipation, on the illusion of becoming. If all moments coexist, then perhaps the I who remembers and the I who dreams are not separate entities, but points of intersection within a timeless structure. In this sense, consciousness might not move through time at all. Instead, time might move through consciousness, much like waves moving through the surface of a still sea. Each wave, each instant of awareness, rises, peaks, and fades, but the sea remains. Awareness is not bound to time. It is the canvas upon which time paints its illusions. For centuries, philosophers like Kant and Augustine suspected that time might be a construct of perception, not an external feature of reality. Augustine famously wrote, "What then is time? If no one asks me, I know. If I wish to explain it to one who asks, I know not." Modern physics seems to echo this confession. The closer we look at time, the less solid it becomes, dissolving from a ticking sequence into a shimmering abstraction. And yet, we feel it. We feel the pull of the future, the weight of the past. We measure it, obey it, fear it. Our lives are shaped by its flow, our deaths promised by its certainty. If time is not real, then what is this feeling that governs every heartbeat, every thought, every tear shed for what is lost? Perhaps it is not the flow of time we feel, but the resistance of consciousness to its own unfolding. The struggle of awareness to define itself within an infinite web where nothing truly passes away. Quantum mechanics teaches us that the universe is not deterministic but probabilistic. The future is not yet decided, but a landscape of possibilities awaiting observation. And yet, if observation itself reaches backward through time, then perhaps the present is also not fixed. Perhaps it, too, is continuously rewritten by the weight of choices yet to be made. Imagine, then, that time is not a river but a fabric, one that wrinkles, folds, and adjusts with every act of perception. Each decision, each observation, alters its weave, sending ripples across past and future alike. What we call the present is simply the place where consciousness meets this ever-shifting fabric, momentarily bringing it into coherence before it continues to reshape itself in response to awareness. This is the quantum paradox of time. It is both real and unreal, both cause and effect, both before and after. It exists only because we observe it, and yet, it shapes the observer in return. In this dance between mind and matter, between measurement and mystery, the universe becomes a mirror reflecting itself. And perhaps, in that reflection, time is not a flow to be escaped, but a language to be understood, a code written not in seconds or centuries but in consciousness itself. If the quantum world whispers any truth to us, it is this: time is not what separates us from eternity. It is the way eternity learns to see itself. There is a silence that lives beneath every heartbeat, a pause between the present and the next moment. It is in this pause, almost invisible, that the illusion of time is born. We are taught to believe in the arrow of time, in its unwavering direction from past to future. Yet, when science peers deep enough into the fabric of reality, it finds no such arrow. The universe itself is indifferent to direction. Its equations do not care which way the clock runs. But life, consciousness, memory, they do. Somewhere between the cold symmetry of physics and the warm asymmetry of experience, time begins to flow. And perhaps it is within this very divide that we find not just science but meaning. Entropy is the first clue. In a universe ruled by reversibility, entropy, the measure of disorder, introduces an irreversible truth. Things fall apart, heat dissipates, systems decay. A glass shatters but never reassembles, a life is lived once but never again. Entropy gives time its direction, its story. From order to chaos, from birth to death. It is not merely a physical law but the engine of narrative itself. At the heart of the cosmos, entropy rises relentlessly. The stars burn their fuel, spreading energy outward. Galaxies drift apart. Heat disperses. The universe cools. It is this flow, this universal increase of entropy, that defines what we call the arrow of time. In the distant future, when the stars have burned out and even black holes have evaporated, there will be no gradients left. No difference between hot and cold, light and dark, cause and effect. Time will lose its meaning. The universe will reach its final equilibrium, a silent, eternal stillness called the heat death. And yet, the question remains. If entropy defines time's direction, what defined entropy's beginning? Why did the universe start in such an extraordinarily low entropy state? A moment of exquisite order, a cosmic improbability. According to the second law of thermodynamics, such order should not exist naturally. The odds of our universe starting with this degree of precision are so small as to be nearly impossible. And yet, here we are, living in a world that remembers a beginning. Perhaps this is the first great mystery of time, that it needed order to begin. Without a low-entropy origin, no arrow of time could emerge. No evolution, no history, no consciousness. The very possibility of memory depends on the asymmetry of the universe's birth. Every thought we have, every recollection, is a monument to that original order. Our ability to remember the past but not the future is not an accident, it is entropy expressed through biology. Memory in this sense is entropy in reverse, an act of resistance. While the universe moves toward disorder, the mind creates patterns, forms connections, builds meaning. Life itself defies the cosmic decay, generating complexity in a sea of chaos. Each organism, each cell, each neuron, is a small rebellion against the second law, temporarily holding entropy at bay. But in the end, entropy always wins. The flame flickers. The pattern fades. The order dissolves back into noise. Still, in that brief defiance, something extraordinary happens. Awareness arises. And with it, time becomes something personal. We experience its passing not as a law but as a feeling, the ache of nostalgia, the fear of aging, the longing for permanence. Entropy is physical, but time as we live it is emotional. It is the most intimate expression of impermanence. Some physicists argue that time itself might emerge from entropy, that it doesn't exist independently, but as a byproduct of statistical imbalance. In this view, the universe at its core is timeless. What we perceive as time passing is simply the unfolding of complexity, the process by which ordered structures dissolve. From the perspective of the fundamental laws, everything already exists. The past, the future, the entire cosmic history. Entropy merely gives the illusion of progression, a way for consciousness to navigate an otherwise static reality. Imagine looking at the entire timeline of the universe as a sculpture, carved in 4 dimensions. Each event, every birth, every death, every star igniting, exists simultaneously within this frozen block. There is no flow, no before or after. We are like travelers moving along one path of that sculpture, experiencing the illusion of time because our minds are structured to move in only one direction. Entropy, then, is the gradient that makes this movement feel real, the slope that turns a static landscape into a living story. But there's a deeper paradox here. If the laws of physics are reversible, and entropy merely reflects our limited perception, then perhaps the universe's heat death is not an end but a turning point. A moment of perfect symmetry where time loses meaning, and then, perhaps, begins again. Some cosmologists, like Sean Carroll and Roger Penrose, have suggested that the end of one universe might give birth to another, through a kind of thermodynamic rebirth. When entropy reaches its maximum, all structure is gone, and with it all distinction between past and future. Out of that perfect uniformity, a new low-entropy condition might emerge. A new Big Bang, a new arrow of time. The universe breathes eternally, through cycles of expansion and silence. This idea transforms entropy from a tale of decay into a story of renewal. Time is not merely a descent into disorder but part of a cosmic rhythm. Creation and dissolution, order and chaos, inhale and exhale. Even as entropy rises, life creates islands of temporary order. Each moment of beauty, each act of love or discovery, is a flicker against the tide, a small defiance in the face of inevitability. In this light, entropy becomes not the enemy of life, but its sculptor. Without decay there can be no growth. Without endings, no beginnings. Entropy is what gives time texture, the contrast between what was and what will be. The stars themselves are born from collapsing clouds of chaos, their brilliance emerging only because disorder seeks balance. Every flame, every heartbeat, every thought burns on borrowed time, and it is this impermanence that gives existence its meaning. The philosopher Henri Bergson once said that, time is creation or nothing at all. Perhaps entropy is the universe's way of creating, of turning potential into form. Each second that passes is the universe reshaping itself, endlessly recomposing its own melody. We, as conscious beings, are notes in that song, transient but essential, contributing our small harmony before fading back into silence. And yet, even as entropy consumes all, something remains untouched. Information, the fundamental currency of the universe, cannot be destroyed. It transforms, it disperses, it hides within the folds of chaos, but it does not vanish. The black holes once thought to erase information entirely are now believed to preserve it, encoded in subtle fluctuations of radiation, written on the very surface of spacetime. In that sense, nothing truly disappears. The universe remembers everything. Perhaps that is the final paradox of time. Though entropy drives decay, memory drives meaning. The universe forgets through disorder, but remembers through pattern. And we, fragile beings of awareness, exist precisely in that tension, between what fades and what endures. So maybe time is not a one-way journey into darkness but a mirror. A reflection of our own struggle to preserve significance against the inevitable tide. Entropy will win, yes, but in losing, it will give birth to all the stories, all the consciousness, all the beauty that ever existed. The arrow of time, then, is not simply the path from order to chaos. It is the universe's act of storytelling, the only way creation could know itself. Through entropy the cosmos learns impermanence. Through impermanence it learns meaning. And so the silence beneath each heartbeat is not emptiness. It is the sound of the universe breathing, the rhythm of entropy and awareness dancing together, shaping time into existence one fleeting moment at a time. There is a boundary the human mind is not built to cross, the threshold between what we call the present and what might exist beyond it. Every second that passes feels irreversible, a vanishing act we cannot undo. Yet, deep within the heart of theoretical physics, a whisper persists. What if the future already exists? What if we are not moving through time but are instead being moved by it, drawn along a path already carved into the geometry of the universe? To understand this, we must step into one of the most haunting ideas in modern science, the block universe. The block universe, or eternalism, proposes that time does not flow at all. Instead, all moments, past, present, and future, coexist simultaneously in a single four-dimensional structure known as spacetime. In this view, your birth, this very instant, and your death are not points along a moving timeline, but fixed coordinates in the vast, unmoving map of the cosmos. The sense of now is an illusion, a trick of perception. You are not traveling from the past to the future. You are simply located at one particular slice of the universal whole. Einstein hinted at this unsettling vision. In his theory of relativity, time is not absolute but relative to motion and gravity. Two observers moving differently will experience different nows. What you perceive as simultaneous events might appear sequential to someone else, depending on their velocity or gravitational field. This means there is no universal present, no single objective now shared by everyone. If now is relative, then the distinction between past and future begins to dissolve. The universe, it seems, contains all moments equally. Einstein once consoled the family of a friend who had died, writing, "For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion." He was not being poetic. He was being literal. The block universe suggests that everything that has ever happened, and will ever happen, already exists within spacetime. The passage of time is simply how our consciousness experiences movement through this static landscape. Imagine a film reel. The entire story, every frame, exists at once. The characters within the film, however, experience those frames in sequence, unaware that their future is already printed, frame by frame, waiting for the light of projection. We are those characters. The universe is the reel. And consciousness is the light that moves across it, illuminating one frame at a time, giving us the illusion of unfolding life. If this is true, then free will becomes a troubling question. If every moment already exists, are we truly choosing, or merely experiencing choices that were always there? Are we agents of creation or actors performing a script written by the geometry of spacetime? Determinism, once an ancient philosophical problem, finds new life within the block universe. Our choices, feelings, triumphs, and regrets may be timeless structures, as real and unchangeable as the stars. But the human spirit resists such fatalism. We feel our choices. We suffer their consequences. We rewrite our lives in the stories we tell ourselves. Perhaps the block universe does not eliminate free will but redefines it. Maybe freedom lies not in altering the structure of time, but in the conscious act of moving through it. Our experience, the way we interpret each fixed moment, could be the true act of creation. The geometry of spacetime may be fixed, but meaning is not. Physicists like Hermann Minkowski, who first formalized spacetime, described it not as a stage where events occur, but as a substance, a single unified entity combining space and time into one. What we perceive as motion, as change, is the result of how we slice this four-dimensional block into three-dimensional cross-sections. Every now is just one such slice, one thin layer of the eternal whole. From a higher perspective, there is no movement, only structure. Every second, every life, every epoch of the cosmos exists together, eternally still. And yet, this picture of timelessness is not cold. Carries a strange beauty. Within the block universe, loss and death are not true annihilations. Every moment that has ever existed, every embrace, every sunrise, every laughter shared, still exists, preserved in the eternal architecture of spacetime. The loved ones we mourn are not gone. Their coordinates are simply behind us in the block. The moments we dread in the future already stand before us, waiting for the light of our awareness to reach them. But this concept also reshapes how we understand consciousness. If all moments exist equally, what gives us the feeling of flow, of moving through them? Some scientists suggest that consciousness itself might be the mechanism that generates the illusion of passage. The mind, constantly integrating memories and sensory input, creates a narrative of continuity, a psychological motion. The arrow of time could therefore exist only within awareness, not within the universe itself. Time, as we experience it, might be the story consciousness tells itself to make sense of existence. This idea intersects beautifully with ancient philosophy. Long before Einstein, mystics and sages spoke of reality as timeless, an eternal present in which all things arise and dissolve. The Hindu concept of Brahman, the Taoist notion of the way, and even the Christian vision of God as the Alpha and the Omega, all reflect the same insight, that creation is not unfolding in time, but is time itself, complete, simultaneous, and unchanging. The block universe gives scientific shape to this ancient intuition. Yet there are those who resist this view. The British philosopher and physicist Sir Arthur Eddington called the flow of time something deeply rooted in our consciousness. He argued that even if physics describes a frozen universe, our experience of becoming, of transformation, is not an illusion, but a fundamental aspect of reality. Perhaps the universe is not static but layered, both eternal and evolving, both block and flow. Some physicists are exploring models that attempt to reconcile this, proposing that the universe might be a growing block, not a completed one. In this growing block universe, the past and present exist, but the future does not yet. The block expands as new moments crystallize into being. This model preserves the reality of the past while maintaining the openness of the future. Time, in this view, is creation itself, the universe expanding not just in space but in meaning. Still, the deeper we dive into these concepts, the more we sense that all these frameworks, eternal block, growing block, flowing river, may be metaphors for something our minds cannot truly grasp. We are creatures bound by sequence, trying to imagine existence without before or after. It may be that time, like color or sound, is a property of perception, real within experience but not fundamental to the structure of the cosmos. If the block universe is correct, then everything that has ever been, every civilization, every thought, every whisper of wind through the trees, is forever. And yet, paradoxically, that forever is not static but alive through awareness. We move through it like travelers across a vast landscape, glimpsing the eternal one horizon at a time. There is comfort in this idea and terror too. Comfort because nothing is truly lost. Terror because nothing can ever change. But perhaps both emotions are part of the same truth, that eternity is not found at the end of time, but within every moment. The present, when fully seen, contains all of existence folded within it. Maybe that is why, when we lose ourselves in awe, in art, in love, in the quiet immensity of the night sky, time seems to stop. For an instant, we step outside the illusion and glimpse the eternal structure behind it. In those rare moments of stillness, the universe feels not like something moving past us, but something we are inside, vast, silent, infinite, and whole. And perhaps that is what the block universe has been trying to tell us all along. Not that time is meaningless, but that it is already complete. Not that we are trapped, but that we are forever part of something that never ends. The timeless geometry of being, where every moment, every life, every atom of existence stands eternally illuminated in the endless light of now. In the vast silence between galaxies, time behaves differently. Not because clocks tick slower or faster, but because the very meaning of time begins to dissolve. In deep space, far from gravity, far from motion, far from the anchors of human perception, there is no sunrise or sunset to mark the passing of moments. There is only the endless hum of cosmic background radiation, a whisper left over from the birth of everything. To an observer adrift there, alone in the void, time would lose all reference. Seconds would stretch, hours would blur, and eventually the mind would forget how to count at all. It is here, in this emptiness, that the nature of time reveals its truest paradox. It is both everywhere and nowhere, both the fabric of reality and the illusion that holds it together. The deeper physicists have looked into spacetime, the stranger it has become. What once seemed like an unshakable stage upon which events unfold is now understood as a dynamic field, one that bends, stretches, and vibrates with energy. In general relativity, massive objects curve spacetime, causing what we experience as gravity. In quantum mechanics, the vacuum itself is restless, filled with fluctuations and virtual particles flickering in and out of existence. When these two views are combined, a tension arises. Spacetime cannot remain smooth at the smallest scales. It must foam, ripple, and fracture. This chaotic quantum granularity is known as Planck time, the smallest meaningful interval of duration, beyond which before and after lose definition. Below this limit, time ceases to be continuous. It becomes pixelated like the static on a cosmic screen. If time is not continuous but quantized, then perhaps it does not flow at all. Perhaps it flickers, each moment emerging, vanishing, and re-emerging like the frames of an infinite film. Between those frames lies the true mystery, the nothingness that connects everything. The philosopher's now may not be a moving point along a timeline, but a pulse, a beat in the universal rhythm. What we experience as motion through time might be nothing more than consciousness synchronizing with the heartbeat of existence itself. But if that is so, what lies between those beats? Is it silence? Is it eternity? Or is it something stranger, the place where reality resets itself, recreating the illusion of continuity again and again? Some quantum gravity theories, such as loop quantum gravity, attempt to describe this microscopic architecture of time. According to these models, spacetime is woven from discrete loops, tiny interconnected quantum threads. The universe, in this view, is not a continuous expanse but a vast network of information nodes. Time is not a flowing river but a series of quantum updates, each tick representing a transition from one state to another. The flow of time emerges from the sequence of these updates, not from any intrinsic motion. The universe, it turns out, may not evolve in time, it may create time as it evolves. And yet, within these quantum fabrics, an even deeper question emerges. Could time be an illusion altogether? If the equations that describe the universe are fundamentally timeless, as many cosmologists now suggest, then what we call time may be nothing more than a shadow of change. In this interpretation, reality is not a process but a configuration. All possible states exist, but only one is perceived at a time, giving rise to the illusion of motion and transformation. The Italian physicist Carlo Rovelli describes it this way: time is ignorance. He means that time emerges only when we ignore the fine details of the universe. When we zoom out, when we average over countless quantum interactions, patterns arise that look like flow, like sequence, like past and future. But at the most fundamental level, there is no such thing. There are only relationships, between particles, between fields, between moments. Time, in this view, is the language we use to describe change, not the cause of it. If this is true, then the cosmos may be timeless in essence but alive in appearance. The world we see is a projection, a simplified view of something deeper, something outside of time. Our perception of the future approaching and the past receding might be like watching waves on the surface of the ocean, unaware that the depths beneath are still. This timeless view, though born from physics, echoes ancient philosophy. The Buddhist notion of impermanence, the Hindu concept of Maya, and even the Platonic idea of eternal forms all point toward a reality that is changeless beneath the illusion of change. What we experience as the passage of time might be consciousness traversing different layers of the same eternal structure, much like a beam of light refracting through the facets of a crystal. Each facet, each moment, reflects a different angle of the same infinite whole. And yet, despite the beauty of this idea, the human heart resists it. We live by moments, by the pulse of days and years. We mark our lives by what is lost and what is remembered. A timeless universe may be mathematically elegant, but emotionally unbearable. To exist in a world where nothing truly changes is to strip existence of its story. The soul craves progression, the promise of becoming. Perhaps, then, the illusion of time is not a mistake but a mercy. Perhaps consciousness, by creating the sense of sequence, grants the universe the gift of experience, the ability to feel its own unfolding. Without time there can be no longing, no curiosity, no evolution of thought or love. Time may be illusion, but it is an illusion that breathes life into eternity. In some interpretations of quantum cosmology, this paradox is expressed through something called emergent time. The idea suggests that time is not a fundamental property of the universe but arises from entanglement, the quantum interdependence between systems. When two particles become entangled, their states are correlated. When one changes, the other responds. This correlation gives rise to what we perceive as before and after. In other words, time may be the measurement of relational change, not an independent dimension at all. From this perspective, time is born from interaction. Without connection there is no motion. Without relationship, no story. Every second we experience is therefore not just a unit of duration, but a reflection of the universe's relational nature. A measure of how deeply everything is entangled with everything else. The flow of time is the music of the cosmos communicating with itself. And perhaps this communication is not limited to the physical. If consciousness is part of the same universal fabric, then awareness, too, may participate in the creation of time. Every act of observation collapses possibilities into reality, carving a path through the timeless field of potential. We do not merely witness time, we generate it, one decision, one perception, one heartbeat at a time. Imagine, for a moment, that each breath you take is a quantum update in the universe's story. Between one inhale and the next, the cosmos recalibrates itself. Reality flickers, imperceptibly but with infinite precision. Each flicker is a frame, and consciousness is the projector. The movie of existence plays not because time flows, but because awareness illuminates one frame after another, stitching them together into meaning. If we could step outside this sequence, if we could see the full film at once, we would find that nothing truly moves and yet everything happens. The Big Bang and the end of the universe would coexist in the same eternal instant, like 2 points on a single, boundless circle. There would be no before, no after, only is. It is a vision both humbling and liberating. Humbling because it reminds us that our greatest certainties, past, future, the ticking of the clock, may be artifacts of perception. Liberating because it suggests that within every moment, eternity already exists. The present is not a fleeting instant slipping away into memory. It is the whole of existence, momentarily seen through the narrow window of awareness. Perhaps then the question is not what is time, but who is time? If consciousness and time are inseparable, then every living being is a facet of the universe's attempt to know itself through the experience of change. Each thought, each heartbeat, each loss is part of that great cosmic inquiry. The stars burn, galaxies spin, atoms vibrate, and through it all, time hums softly, not as a law but as a song. A song without beginning or end, sung by a universe that does not move, yet forever dances. In the final frontier of physics, where time and space collapse into abstraction, there lies a mystery so profound that even the language of mathematics trembles before it, the black hole. It is a place where the known laws of reality surrender, where gravity becomes infinite and spacetime folds in upon itself. In this abyss, time no longer behaves like time. It slows, bends, and eventually stops. The black hole is the closest thing the universe offers to a mirror, not for light but for reality itself. To gaze into it is to see what happens when time forgets how to flow. Imagine drifting toward a black hole, a monstrous star that has collapsed under its own weight, its mass compressed into a point of infinite density. From a distance, it looks deceptively calm, a sphere of darkness against a field of stars, surrounded by a shimmering halo of light. But this calmness is an illusion. The boundary surrounding it, the event horizon, marks the edge of time's domain. To cross it is to cross into eternity, where every second on your clock becomes an infinity to the outside world. For the falling observer, time seems normal. But to anyone watching from afar, you appear frozen, suspended forever at the edge. This paradox is not just poetic, it is real. It is the essence of general relativity's prediction, that gravity can slow time itself. Einstein's equations tell us that the stronger the gravitational field, the slower time moves. Near a black hole where gravity is absolute, time halts altogether. A single second at the edge of a black hole could equal billions of years elsewhere. The universe outside could live and die while for you nothing changes. In that sense, the event horizon is not a wall of matter, it is a wall of time. But what happens beyond that wall is a question that divides science itself. According to classical physics, the center of a black hole, the singularity, is a point where spacetime curves infinitely. Density becomes infinite, and the laws of physics break. But infinity is not a real number. It is a sign of failure, the signal that our understanding is incomplete. To truly comprehend the black hole, we must look deeper into the quantum realm, where spacetime is not smooth but granular. At that scale, something remarkable begins to happen. The singularity, instead of being a point of infinite compression, might be a bridge, a fold, or even a reflection. Some physicists, including Stephen Hawking, speculated that black holes may not destroy information as once thought. Rather, they might encode it on their surface like cosmic hard drives. The information of everything that falls in light, matter, time, could be preserved as a faint quantum hologram on the event horizon. From the outside, the black hole would appear black, but within it, every moment that ever crossed its boundary might still exist, frozen beyond reach yet never lost. This idea, known as the holographic principle, suggests something astonishing, that the entire universe may function like a black hole. Every region of space could be a projection of information stored on a distant boundary. In that case, time itself might not be fundamental, but an emergent property of this holographic encoding, a way for the universe to process information sequentially. What we perceive as the flow of time could be the unfolding of data across a cosmic screen. If that is true, then the black hole is not an anomaly. It is the universe in miniature, a microcosm of the whole. Each black hole could represent a point where reality reflects upon itself, where the fabric of time curls backward and inward, like the pages of a book being read all at once. The title of that book would be When Time Folded Inward. But even this does not end the enigma. In some theories, the inside of a black hole does not end in a singularity but in another universe. The collapse of matter could be a kind of cosmic recycling, where the death of one spacetime becomes the birth of another. A black hole here might be a white hole elsewhere, an explosion, not an implosion. In that case, our own Big Bang could have been the inside of a black hole in another cosmos. Time, then, would not be linear but recursive, eternally folding and unfolding through cycles of creation and collapse. If such a vision were true, it would mean that time never truly begins or ends. Every collapse gives birth to another expansion, every death conceives a new birth. The arrow of time, instead of pointing forward, might spiral infinitely, looping through the fabric of multiverses. In one universe, time flows outward, in another, inward. The cosmic tapestry would not be a line but a labyrinth, and at its center, perhaps, lies the truth we call eternity. Yet, black holes do not just challenge the nature of time, they challenge the nature of causality itself. Inside them, cause and effect can reverse. Space and time switch roles. What was once distance becomes duration, and what was once duration becomes distance. It is a realm where the future might cause the past, where endings precede beginnings. The very logic of reality folds under the weight of gravity's absolute rule. In that reversal, perhaps we find a reflection of our own perception. To an outside observer, the black hole appears timeless, a static shadow that devours all. But from the perspective of what falls in, there is still motion, still change, still life. The two perspectives cannot be reconciled, and yet both are true. The universe, it seems, always allows contradictions to coexist when time is involved. It is as if reality itself were built on the tension between what appears still and what is in motion, between what is eternal and what is fleeting. Hawking once proposed that black holes are not perfectly black. They emit faint radiation, a slow leak of energy over billions of years. This Hawking radiation means that black holes can eventually evaporate, disappearing entirely. But if they evaporate, what happens to the information they contained? Does it vanish? If so, it would violate the most sacred law of physics, the conservation of information. If not, then the information must somehow be released back into the universe, encoded in the faint whispers of radiation. This question, the black hole information paradox, remains one of the most profound mysteries in science. Perhaps, in that paradox, lies a clue to the deepest nature of time. If information is never lost, then nothing that ever happens truly disappears. Every event, every moment is eternal, not in our perception but in the universe's memory. Time may feel like loss, but it is actually preservation. What falls into the black hole of the past is not gone. It is simply inaccessible, folded inward, waiting in a dimension we cannot yet touch. In that sense, black holes may not be destroyers but archivists. They may store not just matter but history. Each one could be a cosmic vault of time itself, a library of moments that have fallen beyond the horizon of experience. The universe could be filled with these frozen histories, each one silently recording its own chapter of reality. And perhaps, in some distant epoch when our universe cools and the last black hole fades into nothingness, time will fold completely inward, every story, every atom, every breath drawn back into the singular instant from which all things once emerged. The arrow will curve upon itself, closing the circle. The beginning and the end will meet, indistinguishable. Then, in that infinite stillness, time will not stop, it will transcend. What was once motion will become pattern, what was once cause will become memory. And in that eternal reflection, the universe may finally see itself, whole, timeless, and complete. In the quiet symphony of existence, there is one force that defies explanation more than any other: consciousness. It does not bend spacetime like gravity, nor can it be measured in equations, yet it is the lens through which the universe knows itself. It is the witness of time's unfolding, the one phenomenon that stands both within and beyond it. Consciousness feels time, remembers it, anticipates it, but it is never truly caught in its flow. When time folded inward, it did not simply twist the physical world, it curved the realm of awareness itself. From the moment we awaken each morning, we step into the current of time. We remember who we are, recall where we left off, and project forward into what must be done. Our sense of self is bound to this continuity, a seamless thread connecting yesterday to today. But what if that thread is not real? What if consciousness does not move through time at all, but instead illuminates each moment individually, creating the illusion of flow? This question has haunted both philosophers and neuroscientists. The brain, complex and electric, does not experience the present continuously. It updates in discrete intervals, small windows of awareness roughly every few hundred milliseconds. Between those windows there is nothing, a void of unawareness. And yet, to us the world feels seamless. Our perception of time, then, may be the mind's greatest illusion, a narrative stitched together from fragments of stillness. In deep meditation, some report a dissolution of this illusion. Time slows, then disappears. Minutes stretch into eternity or vanish entirely. There is only awareness, vast, unbounded, unmoving. Neuroscientists describe such states as changes in brainwave frequency, but practitioners describe them as glimpses beyond the veil, moments where consciousness perceives itself free from the machinery of time. In those states, the self dissolves and with it, the arrow of time. Perhaps this is not a spiritual abstraction but a fundamental truth, that consciousness exists outside of time. The body decays, the neurons fire and fade, but awareness, pure awareness, is not subject to the ticking of the clock. It perceives the flow but does not flow itself. It is the stillness within motion, the observer within the dream. Some physicists have begun to wonder whether consciousness might be a bridge, the link between the timeless quantum realm and the macroscopic world of clocks and calendars. Roger Penrose and Stuart Hameroff proposed that consciousness could emerge from quantum processes within microtubules in the brain, delicate structures where quantum coherence might persist even in the warmth of biological life. If true, this would mean that the mind itself operates at the edge of quantum reality, where time behaves differently. Consciousness, then, would not simply experience time, it would generate it. Imagine awareness as a beam of light passing through a crystal. The crystal represents the universe, intricate, structured, filled with infinite possible paths. As light enters, it refracts, splitting into colors, bending into patterns. Each beam represents a moment, a version of now. Consciousness does not move through time, it illuminates one refracted path after another. The illusion of motion arises from the sequence of illumination, not from any inherent flow in the crystal itself. In dreams, this becomes evident. Entire lifetimes can unfold in seconds, or seconds can stretch into infinity. The brain, unbound from the external world, constructs its own timeline. It proves that time is not an absolute experience, it is relative to the observer's awareness. When the mind changes state, so does time. When the observer shifts, so does the universe. The implications are staggering. If consciousness defines time's flow, then the universe itself, which may be conscious at some fundamental level, could experience different kinds of temporality in different regions. Stars, atoms, galaxies, all may be nodes of awareness, each perceiving a version of time unique to its state of being. The cosmos, then, could be a vast symphony of perceptions, each part contributing to the whole rhythm of existence. And yet, there is something haunting about this idea. If consciousness creates time, then death is not the end of time, it is its transcendence. When the brain ceases to function, the personal experience of time dissolves. To those left behind, life has ended. But to the one who departs, there may be no after, no sense of ending at all, only the cessation of the illusion of movement. From the outside it looks like stillness. From within, it might be eternity. Near-death experiences often describe this sensation. People who have clinically died and returned speak of timelessness, of existing in a state where everything happens at once, where past and future blend into an overwhelming now. Some report seeing their entire lives unfold in a single flash, as if every moment they ever lived were accessible simultaneously. Whether one interprets these reports as spiritual or neurological, they point toward a fascinating possibility, that time as consciousness experiences it, may collapse inward at the threshold between life and death. If consciousness truly stands apart from time, then perhaps the universe itself is conscious in some way, not as a mind but as an awareness diffused through its fabric. This is not a new idea. In ancient philosophy, from the Vedic Atman to the Stoic Logos, the cosmos was seen as a living intelligence. Modern physics, too, edges toward similar conclusions. The fine-tuned constants, the self-organizing principles, the emergence of life and complexity, all hint at an underlying coherence, a pattern that seems to know itself. Perhaps that coherence is consciousness itself, experiencing all possible nows at once. If so, then our individual awareness is not isolated, it is a focal point of that universal consciousness, localized for a time in a body, experiencing a sequence that appears linear only because of how we are wired to perceive it. The truth may be that every moment of our existence, from birth to death to whatever lies beyond, is already written into the fabric of reality, existing simultaneously. We are not travelers moving through time. We are points of awareness exploring different coordinates of a timeless field. This would explain the strange phenomenon of déjà vu, precognition, and intuition, fleeting glimpses where the boundaries of time blur. In those moments, perhaps our consciousness briefly steps out of the linear narrative, perceiving the structure from above, like a reader who sees more than one page of the story at once. But to truly grasp this, one must step beyond intellect. The mind thrives on sequence, it needs before and after, cause and effect. The heart, however, understands something different. It senses eternity in love, in art, in silence. It knows that moments of deep beauty or sorrow feel timeless because they momentarily free us from the illusion of flow. Time pauses, awareness expands, and for an instant, we remember what we truly are, not creatures trapped in time but witnesses of it. Perhaps this is why we create, why we tell stories, paint, sing, and dream. Every act of creation is an attempt to touch that timeless source, to freeze a moment of eternity within the river of time. Art is not an escape from time, it is a conversation with it. The artist becomes the bridge, consciousness bending the linear into the eternal. If the universe itself is conscious, then time may be its way of experiencing itself through limitation. Just as a painter steps into the canvas to become part of the story, perhaps awareness entered time to feel the thrill of becoming, the joy of movement, the ache of impermanence. Without time there is no experience, without experience there is no meaning. The illusion therefore is sacred. And maybe, when time finally folds inward, when all motion ceases and every moment collapses into one, consciousness will awaken to find it was never moving at all. It was the still center of the spiral, the silent observer behind every heartbeat, every galaxy, every thought. Time was its dream, and the dream was beautiful. In that awakening, perhaps there will be no end, no beginning, no loss. Only awareness, infinite and calm, reflecting upon itself. The mirror and the light, the question and the answer, the one who watches and the one who is seen. And in that stillness beyond time, the universe will finally remember its true name. At the edge of comprehension, where physics blurs into philosophy and science becomes poetry, a haunting question waits like a shadow at the boundary of thought. What happens when time ends? Does the universe simply stop, frozen forever in silence, or does it fold inward once more, beginning anew from its own ashes? The end of time has fascinated every civilization that ever looked at the night sky. Some saw apocalypse, others rebirth. But in the language of modern cosmology, this question is not myth, it is prediction. And the answers are stranger, more poetic, and more terrifying than anything our ancestors ever dreamed. The universe, according to current understanding, is expanding. This discovery, first made by Edwin Hubble and later confirmed by cosmic background radiation measurements, shattered the idea of a static cosmos. Everything, galaxies, stars, even the space between atoms, is stretching, pulled apart by an invisible force we call dark energy. It acts like an anti-gravity, accelerating the expansion faster with every passing billion years. At first glance, this seems benign, even majestic, an eternal blossoming of space. But look closer and the beauty becomes dread. If this expansion continues unchecked, the cosmos faces a cold, lonely fate, a death not by fire but by silence. Physicists call it the heat death of the universe. In this scenario, expansion continues until galaxies drift beyond each other's horizons, their light fading into darkness. Stars burn out, planets freeze, and black holes slowly evaporate into whispers of radiation. Over unimaginable stretches of time, 10 to the power of 100 years and beyond, even atoms may decay, leaving only a thin mist of photons and subatomic ghosts. Entropy will have reached its maximum. There will be no gradients, no change, no energy left to fuel motion or life. Time itself, driven by entropy's climb, will lose meaning. When nothing changes, there can be no before or after. The universe will have entered perfect stillness, not because it ended but because it ran out of difference. Yet, within this grim vision lies a paradox. If time depends on change, and change depends on entropy, then at the moment entropy reaches its peak, time effectively stops. But physics describes no mechanism for such an ending. The equations do not break, they simply stop evolving. In a way, the heat death is not a destruction but a freezing, an eternal pause. The universe would persist, but its story would cease to unfold. But not all cosmologists accept this quiet demise. Some believe the expansion of the universe may one day reverse. If the density of matter and dark energy were to shift, or if dark energy itself decays, gravity could eventually overcome the outward push, halting the expansion and pulling everything back together. Galaxies would rush inward, stars and planets colliding in a fiery collapse. The cosmic film that once played forward would now play backward. The end would mirror the beginning, a big crunch. And within that implosion, as spacetime curved in upon itself, time might once again fold inward, reversing its arrow. What was once future could become past, and the universe could, in some deep sense, begin again. But the big crunch is not simply an ending, it's a question of symmetry. If the laws of physics allow time to move backward just as easily as forward, why wouldn't the universe use that option? Could time itself be cyclical, not a straight line but a loop? Ancient cultures often imagined such cycles. The Hindu kalpas, the Stoic eternal recurrence, even the myth of the phoenix. Modern cosmology may be finding, through equations, what ancient myth intuited through imagination, that creation and destruction are not opposites, but phases of the same eternal rhythm. In some cosmological models, when the universe collapses into itself, quantum gravity effects prevent a true singularity from forming. Instead, the energy density rebounds, a bounce. This theory, called the Big Bounce, suggests that every Big Bang is the child of a previous universe that collapsed before it. Time does not end, it reboots. What we call the beginning is merely the turning point of a greater cycle, the moment when contraction becomes expansion again. If this is true, then we are living not in the first universe but one of infinite generations. Every cosmic birth is another act in a timeless play, every end a curtain that rises again. But what happens to memory across cycles? Does each new universe inherit the quantum traces of the last, or does it begin completely anew? Could the fundamental constants, the laws themselves, evolve over these cycles, learning, refining, changing? If so, then the universe might be intelligent in the deepest possible way, not conscious as we know it but self-improving through time's recursive dance. And yet, there is another, darker possibility, the Big Rip. In this scenario, dark energy does not remain constant but grows stronger with time. The expansion accelerates so violently that, in the distant future, it begins to tear apart not just galaxies but stars, then planets, then atoms, and finally the very fabric of spacetime itself. Every particle would drift away into isolation. Even time intervals would stretch infinitely long before shattering into non-existence. The universe would not freeze, it would disintegrate. Time would not stop, it would dismember itself. The Big Rip is not just a physical idea, it is existential poetry. Imagine the final moment of the cosmos. Every point in space infinitely far from every other, no connection remaining, no observer left to perceive. In that moment the concept of when collapses entirely. The story ends not with a bang or a whisper, but with silence so complete that even silence cannot exist within it. Yet even that silence might not be absolute. Quantum mechanics refuses to allow true nothingness. Even in the emptiest vacuum, fluctuations stir, tiny bursts of virtual energy flickering in and out of existence. From such fluctuations, some cosmologists speculate, new universes could be born. In this view, the end of one universe becomes the womb of another. The death of time in one dimension births its rebirth in another. Eternity, therefore, is not infinite duration but infinite regeneration, an endless cycle of emergence and disappearance. Perhaps, then, the end of time is not a destination but a turning. When the universe reaches maximum stillness, it folds back upon itself, not in space but in meaning. Every cause becomes effect, every beginning an echo of an end. The cosmos in this model is a mirror reflecting itself across infinite frames. The Big Bang, the Big Freeze, the Big Crunch, all may be faces of the same phenomenon, seen from different sides of the fold. And maybe that fold is not just cosmic but conscious. If awareness is part of the universe's fabric, then when the universe folds inward, consciousness folds with it. The death of time might not be the death of awareness, but its return to origin, the remerging of every separated perspective into a single field of knowing. In that return, there would be no distinction between before and after, observer and observed. The universe would awaken as one, remembering itself as a whole. It is tempting to see this as an ending, the grand finale of existence. But what if it is something subtler? A pause. A breath between eternities. Just as a heartbeat requires contraction before expansion, perhaps the cosmos itself inhales and exhales through cycles of time. Each fold inward is a gathering, a remembering. Each unfolding is a rediscovery, a new act of creation. If the universe is cyclical, then the story of time is not tragedy but art, an eternal return, endlessly reimagined. The heat death, the big rip, the big crunch, each is a stanza in the same infinite poem. Time is not a linear tale that ends, but a circle that dreams itself into being over and over. So, when time folds inward, perhaps it does not vanish, it transforms. The flow becomes stillness and stillness becomes potential. And in that potential the next spark waits. Somewhere beyond the ashes of a dying cosmos, the quantum vacuum trembles. A fluctuation flickers, a field hums, and from the silence, light returns. The first atom forms. The first second ticks. Time, reborn, stretches forward once again, unaware that it has done this forever. When time begins to dissolve, when the ticking of the cosmic clock fades into stillness, something unexpected happens. Awareness remains. It lingers like a faint shimmer beyond the collapse of all things. Consciousness does not belong to time, rather time belongs to it. What we call the end is only the moment when awareness remembers that it was never bound by moments at all. For ages we have imagined time as a line, a current carrying us from birth to death, from beginning to end. But in truth, it may be a circle, a mirror through which the universe reflects upon itself. Einstein once revealed that time bends, slows, and stretches depending on perspective. Quantum physics takes it further. At the smallest scales, time vanishes altogether. The fundamental equations describing reality contain no past or future, only possibility. The universe, it seems, is timeless beneath the surface of our perception. Perhaps time exists only because consciousness requires it to experience change. Awareness turns potential into sequence, the eternal into narrative. Each heartbeat, each memory, is the universe observing itself in motion. Without observers, time has no meaning, just as a story unread has no life. When the last consciousness fades, time may not end, it may simply go unmeasured. And yet, consciousness may never truly vanish. It could be woven into the structure of reality itself, a property as fundamental as gravity or light. When the universe folds inward, perhaps awareness folds with it, returning to its origin, merging into unity. What we call death may be only reintegration, the merging of the observer with the observed. In that moment, the illusion of separation dissolves. Time stops, not in darkness but in recognition. The universe awakens, and remembers that it was never asleep. Beyond the final echo of creation, when all stars have faded and time itself has folded inward, the universe rests in silence, not in death but in reflection. In that stillness, awareness remains, vast and unbroken. What seemed like an ending was only the turning of a page, the inhale before another cosmic breath. The universe exhales, expands, and lives, It inhales, contracts, and dreams. Every rise and collapse, every birth and dissolution, is one heartbeat in eternity. Time we now see was never a line but a pulse, a rhythm through which existence knows itself. Every atom, every life, every fleeting moment was a note in an infinite melody. The stars burned not to vanish but to remember. The cosmos was never ending, it was learning, evolving, folding its knowledge back into itself before unfolding again. And so, as silence deepens, a spark stirs within the void, the whisper of new beginnings. Light trembles at the edge of nothingness. The story that began with the first flash of creation prepares to rise again. Time, folded inward, prepares to unfold once more. The eternal pulse resumes. The universe remembers itself, and breathes,